So what should we know about energy efficiency, and why it is so necessary to talk about this when we talk about high-loaded systems? As we know that high-loaded system is its system when sometimes we have 10 requests for processing, sometimes we have 10,000 requests for processing, and this is very I can't say that unpredictable, but it is very dynamically changed. And previously we talked about structure of this data system which is collect this data and how process this data from one side. From other side, we talked about infrastructure, about some technologies for organizing processing blocks, so processing virtual machine or containers with some application modules for where the requests or can be sent and processed there. And therefore, when it is necessary to think also about energy efficiency, because if we always if our servers or our hardware will work during all time for processing thousands of requests, it means that very huge part of the time it will use energy without unuseful. It is use energy and don't and will not make some useful work, and therefore we start talking about some payload, amount of payload, payload some tasks, yes, or some payload. It means that when we use useful energy, something like this, because we in total our system if it can say so. For example, W amount of energy, consumption of N nodes, W energy, so it's something like this in summary. And so what part of the energy was used efficiency? So we use for some we use energy for real tasks, not for for working, something like this. And actually the theory of energy efficiency is quite spread now and well known. And when we talk about nowadays system, we always can hear we always can hear about energy efficiency. Something so it's like culture or like technology that is used in nowadays information system, or some technical systems where we talk about some tasks which can be solved, and it should be solved with less energy or less used energy resources. Then, so I think it's understandable. Also, when we talk about energy efficiency, we should say said about data processing performance. It means how that useful or payload, useful load of the system is connected or depends on the time. So it's performance. It's drop in this time slot. So yeah, and also if you don't remember, we talk about in what kind of how we can count payload. We can count it by flop. Flop it's одиниця виміру. That means that so it's connected to such resources as RAM, as processor time, as input output channels, some disks. So four main technical resources and computational resources, and these computational resources integrated into one main flow into one одиниця виміру, sorry for flop. So it means part of that computational resources which was used for when we talk about payload, it means that it was used for useful tasks. So how many computational resources was used for good task or for not useful task. So the performance indicator actually determines the workload processing speed in a computing system. So how fast it works. Then also we have such parameter as system availability. It's the probability of the system resources, or it's probability that system resources will be sufficient to process a user request in time received. So it means that how many time it is percentage of availability. So how one minus probability of the loss. And we I think we talk about this parameter with you during this course. We talked about some quality of service and also system availability. It's can show it's describe system from the point of quality of experience, how people see the system. So if it's available, it's again, therefore its availability should be very high. Then according to efficiency criteria, we have to so efficiency criteria, it's a rule that is formed on the basis of selected performance indicators, and always one to make a purposeful choice from a variety of alternatives. What does it mean? It means that we always, when we talk about high-loaded system, when we talk about energy efficiency system, we always have to find best solution exactly for the for the system. So for exactly for this system. And how to find this solution? So we have to actually what has influence into to the energy efficiency? Sure, it means first of all, it's how what is the payload for the system from one side, and then from other side how we process that load. So we should think about should plan how to process load to make it better, to make it more energy efficiency. And this how to process it means it means that you choose some strategies. So for example, always what does mean strategy? For example, maybe you know some algorithm of processing, some жадный algorithm. I don't remember how it is in English. It means that different strategy equal to different amount of energy efficiency. And so we have to find some. So now we talk about criteria to estimate the strategy according to energy efficiency parameters. Optimal criteria used to make optimal decision according to concept of useful utility maximization. So suitability criteria, how is it suitable for us? Also, we can define some optimal criteria is a multiply of energy efficiency and energy speed. Yes, so this we talk about this data processing performance. So how fast it's processed and how effective energy is used. So we can this multiplication between these two parameters can give us the optimal criteria for choosing the best strategy. Also, for sure, we have to talk about probability of availability. Availability should be more than it was proposed but by SLA. So SLA, as you remember, it is service level agreement. So we will have such a question on the test. What does mean SLA or service level agreement? It means that when we propose, so when company of processing when it's a level of how good will be processed your requests, and it can be fixed by SLA. So this agreement, and for sure we have to provide this availability more than it is. So it is maximization task, it's optimization task to maximize this multiply criteria with these restrictions. Why it is without? Okay, energy scalability of the system components means the availability to increase or decrease energy consumption. We talk about that high-loaded system, they have to be scalable, have to provide scalability, because we shouldn't use the same resources for 10 and the same resources for 10,000 requests. So we have to scale the computational resources, and also we have to scale our system of control, energy efficiency control, have to be scaled, depends on the scalability. Sorry, do you hear me? Because I don't hear any word from you.
Yes, we do.
Okay, thank you. Because okay, thank you. So about when we talk about scalability, we have to think about voltage dynamically scaling, frequency dynamically scaling, and combine both these principles. So we it means that system who process energy, high load system, have to provide also such models to control or to manage energy efficiency of the it is the points of nowadays requests. So exactly when we talk about telecommunication, for sure we can if you read, for example, white paper for 6G, for example, from different companies, or no, anyway, one of the main point is from 9 main principles. You can find there that energy efficiency is very, very, very important thing, because they prepare networks for VR, so virtual reality, and they have to provide no have to process no when we talk about huge amount with it's different as some even multimedia content and VR content. So this huge huge no it's different scale of processing, so it's you have to be for sure have to be energy efficiency for support system supporting this telecommunications should be with energy efficiency. So power management, classification of approach for improve the energy efficiency of at the hardware level. We have few no mainstreams, for example, how to say. From one side, it's static power management. From other side, it's dynamic power management. Static power management actually can be provided by users, by developers, by companies who provide the hardware, who make that hardware. So it use energy efficiency principles in static power management for CPU on CPU level, on system level. For example, for CPU level, it can be used some register set optimization or instructions set optimization. So some of these technologies can be provided, and it is usually when you process when you create your application, will create your system, you can't influence on this. But for example, dynamic power management, to make scalable components and make scalable resource management. So both of these is necessary for providing for make the for use less energy in in current moment, current moment. So we have to plan our components as scalable power scalable components, and from other side we have to create or to make some scalable resource management. No, and also we have for both of these some scalable processing, storage, memories, and also for both of for processor and storage, we also have some principles for providing this. And according to management, we can choose from centralized or decentralized concept for make a better decision for processing for the system during it is working. Horizontal scaling and consolidation. According to horizontal scaling or vertical scaling, it's very interesting because when we talk about horizontal scaling, we talk about how it will be how to change size of the subsystem or module to process more or less requests, depends on more or less requests. So horizon scaling is consideration belong to the class of dynamic approaches. Okay. So the management resources main idea to consolidate workload processing on the minimum amount of resources in order to move some resources from active state. So, for example, you have 3 microservices or something like this, or 3 containers. No, anyway, so you have 3 microservices. They do the same work, and you wish to optimize its work. If, for example, if you have more requests, you turn on all 3 of microservices. If you have less load, you can turn on only one. 2 seconds should be close to shut some sleeping mode or some change mode. Its mode should be changed to use less energy. Therefore, this, for example, technology of virtual machines should be no. So you can, okay. When we talk about microservice, I mean that it's some program component which is do some job which is sent to it, and also this job could be actually this job is it is some task, and it can be containerized, for example, or it can be organized by as a virtual machine on so we have to change number of virtual machines, or change number of containers, or change number of microservices to scale the system. Consolidation, virtual machine consolidation algorithm solves for subtasks. Deciding of insufficient load of the system node in order to future mode all virtual machine from it and drive the node to the step mode. So step by step we add or remove the machine. Deciding of excessive load of the node in order to transfer part of virtual machine from one node to another node. It means that we can manage position or placement of virtual machine depends on its scale, for example. So we can put sometimes when it is more, some virtual machine use more energy or more resources than we can process. And this too huge and rising virtual machine is placed on the same server. We can use migration for reducing load on one physical server. And for sure, this load should be, how to say, this payload, this no, it's one of the, we talk about these principles. It migrate. We talk. It calls migration from of some nodes on from one physical server to another physical server, and it's also horizon scaling. Also selection of virtual machine for relocation from overloaded nodes. I told about this placements of virtual machines selected for relocation on other active or reactivated nodes. So when we have such instruments as moving this machine from one to another, we can plan, or we can organize our physical resources based on its load. So if we don't need more than one, for example, node of one virtual machine, we can it's flexible. This technology is flexible to for organizing these resources. Virtual machine consolidation is 30% limited impact of it. It means that it really use less energy. It really uses less energy, and you can energy efficient. You can save more than 30% of 30% and even more, because when you make a scalable system, your system use only that good payload, comparing with do nothing with another. Also, I propose. Do you have question on this stage? Okay, if you're not, then analysis of energy efficiency management method. Its method, this method uses the all information about from monitoring the system. For example, based on this monitoring data, you can decide that how server or how cluster works with low efficiency, with medium, with high, and also how huge is load to these resources. And so we can plan, or we can think about, or we can start to shut down some resources, depends on its load. For example, Autopilot approach used by Google to solve the reduce so-called slack between maximum possible and actual use of available resources. Also combining horizontal and vertical. Sorry, I didn't say nothing about vertical resource scaling. So horizontal scaling, it's when we can use more resources for one node, and vertical when we can add different nodes. Depends on for the it's so we depends of it is necessary. So it's how to scale the system, and it gives us more possibilities. Also using Borg workloaded scheduler, it is possible to adjust requirements of the jobs minimum computing resources. After pilot allows matching the computational jobs and amount of resources for their processing as accuracy as possible, which reduce the equipment idling for avoiding unnecessary resources reservation. I think when I read, it's not understandable for you at all. It means that you can use these scaling principles for organization of your system, of your resources. Yeah, according to scheduling. So we understand that it depends on how good we organize. So less or more the system will use and will use energy efficiency. Anyway, you can also plan no, for example, because it calls load balancing. So you can use some principles or some technologies to organize queues. You remember we talked about queues, for example, some RabbitT queues, about Kafka queues, with some different principles, post and PON, or something like this principle. So you can organize queues in such way to save energy efficiency of your system. It's yes. Say I think you heard about this, but I can't not say because when we talk about scheduling, first of all, we think about first in, first out. First come, first served, then first in, first out. Or we can speak about round robins, two main principles when we make some few, some not only one queue, and take from each queue step by step. And so anyway, we can think or we can find such strategies where you can how to say, especially special principle to choose the best, for example, request, and it gives you it gives you possibility to save energy, actually, because for example, no, it's one of ideas. For example, you have only one so for example, you have one kind of request. This request is sorry, it's evening evening lecturing. Sometimes it's like somebody takes off some part of you from your mind, and you can't connect to two sentences previously and next one. So I want to say that scheduling or using the best way of request processing can save a lot of energy. So from one side, from previous slide, you can see that you can scale resources, scale a number of nodes. From other side, you can plan request, schedule a request between nodes, and or even organize scheduling on to the one service, and it will save a lot of energy. So it's no, actually, if you you are interested in this question, you can find different lots of scientists nowadays talk about how to save energy, and they propose different notes, or they propose different principles to save energy. So the different methods how to save energy. So we just look through each of it. Also, when we cooperate to the tier energy average scheduling, yes, you can schedule requests for energy efficiency processing in different levels. From one side, it's local level. When the resources, sorry, when you look local level, when, for example, you have one when you have one node, and you can plan resources or schedule resources of this node. You can schedule a task on this node. From other side, you can from other side, you can talk about some global level. When you talk about global level, we talk about distributed computing system, when lots of territorial spread nodes make the same or pretty the same tasks, and these tasks is so you can use this distribution for better energy usage. So you can plan, not plan, you can limit it, or put or schedule requests between these nodes, and also all this gives us some saving, some saving energy, some energy efficient computing. Then this distinguishing of algorithm that after consider the service energy consumption model. I told you, if you will looking for the technology of energy consumption, mainly they are divided between, no, it's main classification. You can use each of them, depends on your necessity. No, for example, there are two main principles of how to pack jobs on the. What does it mean? It means that sometimes when we talk, yes, we talk just about in general, I have to say some words how it, what you can see in this slide. For example, you have you have a system, processing system, which is process high load, and you know that it's necessary to plan something or to manage some energy efficiency processing, computing, and so on. And the main, for sure, your no, now we can't speak about one task, one computer, for example, or one task, one. So it means that, for example, you have some amount of CPU, yes, and you have to plan how use this CPU for different tasks. And as you see, if you have this all the gray and light gray, these both elements, it's tasks which is used during some period of time, for example, during this period of time, use this amount of CPU. Same next and next. So what you can do, you can say, okay, first in, first out. From other side, you can say, I have to make more in the same time. So you can see even not so much, so the same amount of amount of requests processed by with using this principle, backfill principles, which is called, say that we have to complete all resources what we need, even because, for example, this first in, first out, first in, first out. But if you have a queue, so you have some, you can choose some additional, for example, tasks, for example, this one, and make replacement of this time tasks depends on your necessity. Therefore, you can save not bad amount of energy. When we talk about balancing, curing balancing, we talk about some queue. For example, main scheduler have to receive all requests. It's just a model. Actually, when we talk about actually in our work, we need some models from one side, which is model the real system from, and some methods. Methods is used for making something, how to do this, how to do that. Model just describe this. So now we have model or mathematical model of the processing request. When you have the main scheduler, you have some, in this case, n or 3, if n elements, processing elements. This n processing elements has its own queue and its own scheduler. So you can send information or spread or send information for few nodes from one side, and from other side you can manage also each queue to this different server. Also, this system has some balance control and some monitoring of the queuing, and depends on data from this monitoring. you can make a solution how to balance the information between the requests. So you can use, here you can see different mathematical models of processing requests. For example, how many nodes, how many elements in the queue, and so on. So it's different one. Graphic representation of the transformed QS. It is transformed because QS. It is transformed because it can be managed. Yes, it's all balancers have to use this energy efficiency strategy, and therefore these energy efficiency strategies has can be described like this. What does it mean? For example, we have groups of requests can be grouped, and these groups of requests can be we can model it as a person stream, and where we can have zero or a lot of requests in the same time. And then we have to divide the tasks between processing nodes, and it should be, I don't remember how it works. So it so we have to plan, depends on these classes of the request. We have to plan how to schedule each of these class to each of the server. What is model definition? Okay, main components of a computing system power consumption, of which it takes into account. So main, as I told you, main elements is four. It's CPU, GPU is group, maybe processing unit, and RAM elements, some elements for of the persistence memory, and if it is viable, it's display. There is some main idea of this is that when we talk about energy consumption or power, when we talk about some power, as you remember, P it's our useful energy in the moment of the time, as I remember. Right, just a minute. Need to see. P is probability. Okay, maybe I'm not right. What does it mean? It means that total power, yes, total power consumption of computing node for each considered level is can be calculated like this. So it's power consumption of each module of processing, each of processing resources. So CPU, GPU, RAM, hardware. So it is our total energy, consumption. Then we can, when we depends on how it used these resources, we can build we can build some function which is show how energy depends on depends on useful payload of this or that resources. So we very fast from task, from some no organizing this task, how application. We go to exactly hardware description. So all these parameters, all these parameters is can be estimated by physical devices or by some program models who count that energy. And it was developed that actually we have some function of CPU. So we depends on usage resources. Power consumption depends on computational resources usage. So why we need this dependency? Why we need this formula? Because really we can prognose, or we can plan after we can plan how to work in the future. And this how to work in the future, we it is no, this function is these functions will be different for different nodes or for different tasks, and therefore before using this formula or this estimation, we have to estimate or test the node and find this function, dependency function, to make new decision after. For example, when we how depends on, or how yes, how depends how the energy depends on tasks, or energy efficiency depends on the power. Power it grows by its linear function, and it grows by well-known закон, law. But according to energy efficiency, we have some classical, I mean that we make lots of experience, and mainly this energy efficiency line was not linear. It was like this, and therefore you can't use you can't use this result, or you can't you can use this result, but you have to find your personal, your own dependency for different for different technical resources, for different tasks, and so on. Actually, now it is 18:30. I think I will look through what I want to say more, but it is the main principle. The main principle is that this energy efficiency dependency is have to be built for real system before it's and based on this we can make our system better. I think we talk about this on different, but anyway, when we speak about energy efficiency, about high loaded, about distributed computing system, we have to understand that we talk about such kind of elements, and which is connected with each other, and have no. So it's a huge, very huge number of nodes which is connected, and its work depends on the structure organization, but depends on the management or hypervisor of this system. So I think you can understand that when you use so huge amount of tasks, you have to think about to plan energy efficiency on your system. Optimization energy consumption. It's really it is different kind of it's kinds of some solutions which is show how to use how to use this scheduling structure or how to use this queuing structure for scheduling requests on the best way. What else? What else? Processing to ensure functioning of the server cluster, the system. Just a minute. I will. Just a minute. I think we can stop for now for this lecture. I will look through. So in total, to talking about energy efficiency, we should organize functioning of the server cluster, also the system who runs the distributed data processing software, which have to responses for next one. It should be coordinated operation of all services. Also resolution of conflict. So some conflicts should be solved also. Server cluster recognition, configuration in case of failure. So we have to be sure that if something is bad, then our system will be stable, will work as usual, reconfigure and work as energy efficiency system. Then server cluster reconfiguration in case of failures. I told about this. Workload distribution or scheduling between cluster nodes. Also cluster scaling to adapt amount of resources to need of workloaded processes. And for sure, we have to have monitoring of hardware resources or elements to make this better. Do you have questions for me? Okay, if you don't have, I will add this lecture and I will add the next test, and maybe next week we can see who can receive the marks or not. So it was the last lectures. Thank you very much. Do you have questions?
No, we don't.
And